different than I detailed it in third period because there was some confusion in third period. There are a lot of interesting problems that deal with pulleys, and I've stayed away from the pulley questions. You notice the questions I focused on last week were all rolling questions, where we were dealing with problems where something would roll down a ramp or up a ramp or across a level surface. As we look at the coursework, the idea that you can have pulley questions, I think, is pretty obvious. And as we look at what they're going to write for this year's exam, there's no telling how they're going to test that. This problem I like because it was actually an AP question from just a couple of years ago, 2013, I think. For those of you who want to just look it up and cheat on your homework tonight, that's where you would go. And it was the second problem or the third problem on the test. They had an arrangement that looked like this, where the object here was a disk of mass m and radius r. And they actually gave value to this. They said the mass was 2 kilograms and the radius was 0.1 meter. And they did say it was a disk, which means you should be able to compute the moment of inertia as 1/2 mr squared. They said that there is an applied force here. And question A was relatively benign. And I'll ask it just for the premise that we're looking at the way the FRQ was shaped. They ask if the system was at rest, what was the value of the applied force? Now, I don't really think that that's going to be a hard question, but I will give you guys 30 seconds or so to tell me the answer. If you left in terms of the given variables, then yeah, net force equals 0. You had 2 tensions pulling up and the weight pulling down. So FA was half of the weight, which is 10 newtons. Now, that part wasn't particularly challenging. It's the next question that's a little tougher. And it's in this next question where I'm going to let you guys take a break and talk amongst yourselves. I'll break you up into groups because I think some of you are going to want to have bounced off your ideas off of somebody else, anybody else. Because they say that they increase the applied force. So that's greater than half the weight. And I don't have to tell you what it is, but in the problem, they increase it to 12. So if you want a number, there you go. But you just have to understand that FA is going to be increased greater than half the weight, which suggests then that the system is going to accelerate upwards. Moreover, they state that the object does not slip with respect to the rope, meaning the object is going to rotate. So it'll have a linear acceleration and an angular acceleration. The question asks for the linear acceleration next. That's what question B is, the linear acceleration. So I'm not going to ask that quite yet, but as a means to get there, how would you set this up? I want you to think about it. Think about your net force and perhaps your net torque equation, and be prepared to answer the question, how would you set this up? And I have some specific things I might ask, like where would you put the fulcrum and what would your torques look like? All right? So I'm going to break you guys into groups so you have a chance to talk this out. We're going to take about 2 or 3 minutes. And then again, we're going to play Wheel of Participants and find somebody here who can answer my questions. So there you go. Go find a group. Actually, you're being assigned to a group, so you don't have to find a group. Yeah. And if you need me, call me. I'll pop into your group. Hey, Vaughn, you sticking here with me? I'm in session. They're in their breakout groups.
Like, can they hear me?
They can't hear you now.
Okay. I just got off the phone with Maga.
Yeah. That's a rough sweatshirt.
Well, it is from 2017. It's 3 years
Dirty.
old. I washed it last night, though. So.
Good.
I washed that and the shirt.
So it's like a virtual boyfriend.
We're not boyfriend. I mean, girlfriend.
I didn't say that. So it's like
okay.
a virtual boyfriend.
Okay. Also, just another sweatshirt for my collection. Yeah. We talked about art, talked about school, talked about the virus.
Good.
And told her about the concert because Susan mentioned it to her. So.
Yay.
It's just, you gotta wait until she's completely done saying what she needs to be said in order to say what you're gonna say.
Oh, yeah.
It's
It's just the way it is.
Yeah, it's alright though.
They're all coming back now.
I don't think so. I've seen them.
They will. They'll start being back here in a minute.
Okay. So.
There they come.
Yeah. So now. Oh, shit, what was I gonna say? So I have around 2 hours and 30 minutes before my registration opens. And I thought I had a meeting today with my advisor.
You said it's tomorrow.
Yeah, I was really,
Yeah.
I was.
Do you have to wait 2 hours before it opens up?
It doesn't open for me until 3 p.m. So I have 2.5 hours.
All right, I gotta get back to this, okay?
Okay, bye.
Bye. All right. We're still waiting on a few rooms to empty out, but almost all back. Almost here. Come on, everybody.
Yeah.
All right, that's enough. We have to get started. All right, glad you all could come back. So, a couple of questions for you. And this one, I just want a yes or no in the participant window. So, where did you put the fulcrum for this particular problem? Raise your hand put yes if you put your fulcrum at the center, and put no if you put your fulcrum someplace else. All right, so I see I've got about a third of you said no. So, Jason, where did you put the fulcrum? Right there? All right. Now, you guys can make either choice. But I want to be very cautious about this particular choice, because sometimes this choice is arbitrary in that it won't make any difference to your work. But sometimes making this choice can make your problem easier. It's going to be still work, and there's not a wrong way to do this. On the other hand, the pivot point is actually here. This is where it's going to pivot. This is all going to get lifted up as we pull up on the rope. So one of these is an actual pivot. But there's also a mathematical consideration. The moment we pull up with 12 newtons here, there is not 12 newtons here. These two tensions will not be the same. This is going to be something different. And the reason has to do with the fact that the system is spinning. The only way the system can spin about its center is if there's an unbalanced torque. So those two upward forces can't be the same, which means this is an unknown. And you have to treat it as an unknown in the problem. Now, that's not a big deal. If you make your pivot point here, you're going to get a value for t in it that will represent the net force acting upwards on our disk. And if you deal with net torque, you're also going to get a t in your answer. So you will have two equations that have a shared unknown t, the tension. But if you place your pivot point to the left, which is where I'd like to talk about it for this problem, then the pivot point is placed on top of where the tension is applied, which means that the torque from that particular tension is 0 because it's applied at the pivot point. So I want to put the pivot point there. One of the things I've tried to encourage you to do is place the fulcrum at places that will eliminate unknown forces. And the upward tension on that side is an unknown force. So that suggests we'll do a net torque equation, set that equal to I alpha. And there will also be a net force equation, which is going to be equal to ma. They want the linear acceleration, but we can't get that from the net force equation. The net force equation is going to give us T plus the applied force minus mg equals ma. And we just can't solve that. On the other hand, net torque might give us something that we can do. How many torques act on the system? Just hold up a number of fingers. How many torques act in the system? Got a few of you there. Yeah, it would be 2. Because we have the obvious torque that comes from that applied force. And it's going to cause a counterclockwise torque, or one that, using my right-hand rule, comes out towards me. But there's also going to be a torque from the weight, which is going to be a clockwise torque, which means into the page. So there are 2 torques on the system, and every torque has 3 parts. So let's consider that we have 2 torques, each with 3 parts. This torque is from the applied force, and this torque is from gravity. So I have R, F, and sine of the angle. So I think we can probably fill this in now with this being 2R. Right, the torque arm length is from the pivot to where the force is applied. That's the diameter. Did you see that? Don't want to make that mistake. Times FA, which is 12, times the sine of 90. On the other hand, we're going to have R here, because the center of mass is at the center of the disk, times mg times the sine 90. Any question about that? Because that's going to have to equal I alpha. But herein lies the problem with doing it this way. We can't use the moment of inertia about the center of mass. We have shifted our pivot point to the edge, so we have to use the parallel axis theorem, which is going to be I center of mass plus how far we've shifted it. Now, this will give you alpha, but be careful. That's not what the question asked for. The question asked for the linear acceleration. Now, you can get the linear acceleration, but be careful. We have alpha about this point. So in calculating the linear acceleration, we're talking about the linear acceleration of the center of mass. That's here. Now, we're going to end class here because we're just about out of time. And I try to make the class portion no more than 30 minutes, and we're at like 22. So here's what I'd like you to do. I would like you to consider 3 questions that are actual follow-ups. And I told you what year this is. You can, if you want to just cheat and just look it up. But there are 3 questions that follow after what was the force when it was at rest. Linear acceleration was 1. Angular speed after 3 seconds was the other. And the change in mechanical energy after 3 seconds was a third. Tomorrow, right before we start class, I would like to take a look at these three. It should only take us about 3-4 minutes. We've done all the heavy lifting. So we're just going to have to put a few in there. And these are numerical answers. You can just provide the numerical answers if you want. All right. Well, I think that's going to be it for today.